Hey everybody, it's Mr. Lowry again. This is some notes and some help and homework help for the day one lesson, which would have been Monday, February 8th if you're in cohort A. If you're in cohort B, this would have been for Tuesday, February 9th. This is the assignment I handed out, and you can find a PDF copy posted in this assignment in Canvas. We'll go through a few of these problems here. I kind of did a combination here. I made this worksheet, but I also included some problems from the book that I thought were kind of interesting or good, or things that you would probably see like on a standardized test. So we'll go over a few of these. Before we do that though, you'll probably just want to review some key language about circles. So in section 10.1, which is where some of the homework problems come from, there's a lot of key terms like, circle, you know what a circle is, but this definition, the locus of all points in a plane equidistant from a given point called the center, is kind of a wordy one, but it's actually an important one that we're going to use a little bit later. In layman's terms, what that means is a circle is really just a group of points that are the same distance away from another point. So if you remember, we talked about this tool for geometry. It's called a compass. It has a point on one end and it has like a pencil on the other one. And what you do is you use this compass, you put the point down, and that's the center, and then this basically becomes a distance. And you spin this guy in a circle and it creates a circle, and each part of the circle, each point on the circle is the same distance away from that center point. So that definition is just saying a circle is a set of points that are all the same distance from a center point. Okay, so you're going to need to know that and kind of have an idea of what that definition is. We also have chord, which may be a new idea for you. Diameter you should probably know, and radius you'll probably know. One thing to note is that a radius, the length of a radius is half the length of the diameter. Okay. Also, another kind of key idea here is that a diameter is a special kind of chord. A chord is any segment where its endpoints are on the circle. If you notice, a diameter is a segment with endpoints on the circle. What's special about a diameter is it's the longest chord you can draw, and it also goes through the center. So those are some key ideas there. You also have the idea of circumference. Down here at the bottom of page 523, it's the distance around the outside of the circle. Kind of would be like perimeter for a polygon, but we don't say perimeter for circles, we say circumference. Okay, and then we're kind of talking a little bit about arcs as well. So this is actually a little bit later. If you look at the very beginning of 10.2, you'll see definition for what a central angle is. So that's an important key concept that you'll want to write down in your notebook. And you'll also just want to know what an arc is. Okay. Now this is several different kinds of arcs, which we'll come back to in 8.2. So you don't need to know all of this information about minor arcs, major arcs, and semicircles, but it is good to know what an arc is, just in general, and we're going to refer to that again on this assignment that we're going to do. So you want to know those key definitions. You also might want to know this idea here. Let's go back a little bit. And this is on page 524. And this is about pi. Okay. Now pi is not a number that was made up. It's actually discovered. Pi is the ratio of circumference to diameter for any circle. And let me see if I can kind of connect that to an idea that we've had before. We talked a little bit about this guy. This is like a special right triangle. This is a 45, 45, 90. Okay? Regardless of how big this triangle is, the ratio of the sides are always the same. Okay? So if this is 1 and this is 1, this is the square root of 2. Okay? And if this is 10 and this is 10, then this is 10 square root of 2. Right? It doesn't matter how big the triangle is, the ratio of the hypotenuse to a leg will always be square root of 2 over 1. That ratio doesn't change. Now this ratio here is kind of funky. If you remember, Pythagoras kind of had a tough time with this root 2 because he didn't really believe in irrational numbers. He didn't think that that was a thing. So these natural ratios sometimes don't come out very nice, but we just kind of have to learn how to deal with it. Likewise with circles, there is a relationship between the circumference and the diameter, and it doesn't matter what size the circle is. That relationship of circumference to diameter is always the same number, and it's always an irrational number, just like this relationship is always root 2 to 1. Okay? The relationship of circumference to diameter is always pi, another irrational number. Okay? So this is an important idea. It also kind of turns into a formula. If you rearrange it a little bit, you get circumference equals diameter times pi. And since we know diameter is 2 times radius, you can rewrite this one more time, and the circumference is 2 times pi times the radius. Okay? So all of those are key ideas here that you're going to want to know. So if you haven't, done this already, if you missed class today, what you're going to want to do is you're going to want to go back and write all those definitions down in your notebook. Make sure you have those handy, because when we talk about things like arcs and central angles and chords and things, you want to know what we're referring to. Okay. Let's switch gears here and let's talk about this worksheet. So again, this worksheet is a combination of kind of problems that I pulled and made up, also a few things from your textbook. So let's look at a few of these. Okay. First thing I want you to notice is that we want exact numbers and decimal approximations for here. We're going to have 2 different answers. It's a good idea to learn how to deal with irrational numbers just like we did with roots. So once again, going back to this idea, if we had a 45, 45, 90, and we said that this was 8, this would have to be 8 over root 2. And we don't get a decimal approximation. What we do is we rationalize the denominator. So we get 8 root 2 over 2, or 4 root 2, and we leave this as an exact measurement. We could turn it into a decimal approximation if we wanted to, but this is the most exact version of that answer. Okay? Same thing is true here when we're using the irrational number pi. So we know that circumference is equal to pi r, or that circumference is equal to pi times diameter. So let's use that to go through a couple of these. Okay, number 1, radius is 5 centimeters, so the circumference is 2 times pi times 5. We can rearrange these using the commutative property, so it'll be 2 times 5 times pi, or just 10 pi. Okay, 10 pi centimeters is an exact answer. Okay. Now, it may not be the most practical depending on what you're doing. So for a mathematician, 10 pi is great. For an engineer or construction worker or designer, something like that, you may want to find an approximation. Okay? So you're just going to do 10 pi. Now, if you're using a calculator like mine, the pi button is kind of hard to see. You're going to have to go shift and then this guy. That'll give you pi. And then hit equals. Now, sometimes, depending on what mode your calculator is in, it's just going to give you 10 pi back. That's a simplified exact answer. But I can use this button, S to D, and that will change it to a decimal approximation. If you don't have a calculator like this, you'll probably have a pi button somewhere. You can also use Desmos.com, which is kind of our default calculator if you don't have one at home. So don't use 3.14, use the pi key, or you're going to be off here. And then we'll round it to the nearest tenth. That's 1 decimal place. So 31.4 centimeters. Okay, so not too bad. All right, diameter is given, right? We want the circumference. That's the goal. Find the circumference. It's giving us the diameter, so we know circumference is equal to pi times d, or pi times 16. We'll write that 16 pi centimeters. There's our exact answer. Okay, once again, if we want a decimal approximation, we're going to go 16 pi, which is about 50.3 centimeters. Okay. All right. Now we're going to go the other way. Okay. If the circumference is given and I want to find the radius. What I know is circumference equals 2 pi r, where r is radius. That means circumference, 12 pi, is equal to 2 pi times r. All right. Now we want to get r by itself because we're solving for radius. And what we can do is we can divide both sides by 2 pi. Okay, we're going to treat pi almost like a variable for a while. It's not exactly a variable because it's not an unknown. It represents a specific known number, but we can kind of treat it like that. So 2 cancels, pi cancels, right? Pi also cancels over here, and then we get 12 over 2, or 12 divided by 2, which is just 6, equals r. So 6 equals r, which means the radius is 6 feet. Okay, so that's kind of how you manage one of those. All right. This one is also going to be backwards. Now, the area formula for a circle isn't in one of those 2 sections that we talked about. So we talked about this in class, but the area formula is pi r squared. Okay, we got to be a little bit careful with the area formula because notice the area formula and the circumference formula look very, very similar. They both have a 2, they both have a pi, and they both have an r. Okay, the circumference formula, you're multiplying by 2. The area formula, you're squaring, which is different. Okay, so keep that in mind. The first thing asks us to find the area. That's what we're trying to find, but given the radius. So for number 7, area equals pi times 11 squared. Okay, don't put 22 here, because this is not 11 times 2. It's 11 times 11, right? 11 squared is 11 times 11. So this is going to be 121 pi. We also got to be careful when we're doing area, the units are square units, right? We're talking about a 2-dimensional area. So this will be centimeters squared. Okay, that's our exact answer. Now we want to find our decimal approximation. So 121 pi is about 380.1. And again, the unit is centimeters squared because we're talking about square area, or 2-dimensional area. Okay. 9 is a little bit trickier. We actually have to kind of do a 2-step process. Now, I should have given you more space for this. That's my bad. I was trying to fit everything on a couple pages so that you didn't have an extra page, but this is actually going to require a little bit of extra work. So I'm going to go to a separate sheet of paper, which you are welcome to do as well, as long as you take a picture of that work. All right, I'm just going to go down here to the bottom. Okay. Now, when you do your homework, we want it to be, in organized steps and things. So if you do this problem somewhere else, just make it clear what you're doing. Okay, so area equals pi r squared, right? That's what I'm trying to find. In order to find area, I need to know radius, okay? So going back up here where the problem's written, I want to find the area, and I don't have the radius. That means I need to solve for radius, okay? So this is what I need to do, but I can't do that yet. So what I'm going to do is I'm going to use the circumference formula, which is 2 pi r, okay? And it gives me the circumference. It actually tells me the circumference is 10 pi. So I can replace that with, I can replace c. So 10 pi, the circumference, is equal to 2 pi r, and now I can solve for r. Okay, divide both sides by 2 pi. Again, kind of treating pi like a variable right now, even though it's a specific number. Pi's cancel, okay, and I get 5 equals r. So the radius is 5 miles in this case. That's the unit, right? And that's not what I wanted, but now I can use that guy, right? I have to use what it tells me about circumference, solve for radius, and then I can plug that back in the area formula. So when we started this problem, we knew that we wanted area, but we knew we were going to need radius to do it. So now area equals pi times 5 squared, or 25 pi. And again, this is miles, square miles. So your unit should be square miles or miles squared. Okay, remember we need an exact answer as well. So we're going to jump in and do 25 times pi in your calculator. Now this here, this squared right here, you don't need to square anything. We already squared the 5. You don't need to do anything with that square. This is just part of the unit. Okay, a mile is a distance in 1 dimension. A square mile is an area measurement in 2 dimensions. Okay, so that's the difference. If you're talking about an area, we're talking about square miles, which is a unit of area, not just a distance. Okay, so that's how you do number 9. Okay, now for arc length, there's a couple ways to think about this. Remember that an arc is this guy. Okay, an arc is a section of the circumference. So this is how I like to think about it. Arc is a portion or a section of the circumference. Okay? The circumference is the distance all around the outside. This is just part of that distance, a section of that distance. So if this was a pizza and this was a slice of pizza, the arc length would be like the length of the crust right there. Okay, so let's take a look at this idea about portion and circumference. Okay, let's look at number 11. Okay, portion. In order to think about what portion we're talking about here, we have this angle to help us. Now this angle right here is called a central angle. It is an angle that's from the center of the circle. So there's the center, the vertex, the vertex of this angle is the center of the circle. So I know that that's 60 degrees, but if you think about the full circle measurement is 360 degrees. And so I have this section, this 60-degree section of a full circle. And so this is like part to whole. Okay, this is going to tell me what portion of the circumference I'm talking about, because this is what portion of the circle I'm dealing with. So you start with finding out what portion that is, 60 over 360. Now that's actually going to simplify. So 60 over 360 is actually 1/6. Okay, so we'll simplify that to 1/6 in just a second. But just so we know, we have a 1/6 portion of the circle. Okay, now we want a portion of the circumference. Okay, so that's the second piece. Now remember, the circumference is 2 pi r. In this case, that's going to be 2 times pi times 13. Okay, so that's the setup. What portion are you talking about? And then you're talking about a portion of the circumference. So there you go. Now we have some simplification that's going to happen. So remember, 60 over 360 is 1/6. Okay, so that turns into that. And then if we want to, we can, rearrange the terms here, or excuse me, the factors, because multiplication is commutative. So 2 times pi times 13 is the same as 2 times 13 times pi, or 26 pi. Okay, well now we're just multiplying basically a fraction by a number, so I'm going to make the second number a fraction, 26 pi over 1, which when we multiply straight across is going to give us 26 pi over 6. Now because there's a common factor here of 2, we want to simplify one more time. So 2 goes into 6 3 times, and 2 goes into 26 13 times, and so my exact answer is 13 pi over 3 feet. Okay, that's the length of this exactly. Now, if you wanted to find out the approximate length, you would use your calculator for that and use the pi button. So 13 pi over 3. It's going to give me, a simplified fraction here. So I'm going to go s to d. So that's about 13.6-ish, in this case, feet. Okay. All right. So that goes with number 11, right? Now the rest of these are set up the exact same way. You start out by finding what portion of the circle you're talking about, and then multiply that by the circumference. There's actually a formula for arc length, and it basically is this idea. I like to think of it conceptually. That makes sense to me. But if you're a formula person, you can say that arc length is equal to central angle over 360, which is what we have here, right? Whatever that central angle is divided by 360. So this is the angle symbol. And then you're going to multiply that by the circumference, 2 pi r. Okay? That's the formula. But again, when I think of arc as a portion of the circumference, portion of circumference helps me set up a ratio, and a circumference I already know. Okay, so that will help you there. Remember, you need approximate and exact. Don't forget to show your work. Give getting this exact answer will help your algebra skills and your fraction skills. Okay, on the back we have a similar idea, but here we want area of each sector. Okay, this word sector is, I don't think it's in your book in those sections. So let's talk about what a sector is. Okay, a sector is like a slice, basically. Okay, so this, we'll do 18 right here. Think of this as like a slice of pizza. A sector is the area of that slice. Okay, the arc length is like the crust of that slice. Okay, so here's how I think about it. Sector is like slice, and we want to find the area. Okay, circumference is like crust, right? C for crust, S for slice. Okay, and then arc length is a piece of the circumference. So arc length would be a piece of the crust. Okay, so we don't want to find the piece of the crust. We don't want to find the arc length. That's what we did over here. Okay, what we want to find is we want to find the area of the pizza slice. Right? In this case, it would be more than a slice. It would be like, what portion of the pizza is this? What's the area of this section, right? This in this case, we have like just a little tiny section. So when I think about sector area, I think of a sector is a portion of the area. Okay. An arc is a portion of the circumference, the outside. A sector is a portion of the full inside area. Okay, so let's do our same kind of idea. So portion, start with portion. We've got to find out the portion of the circle. So this is 45 degrees. Excuse me, I kind of drew over that, but this is a 45-degree angle out of the full 360. So this is going to tell me what portion of the circle I'm dealing with. Okay, now I have to find a portion of the area, and remember an area is pi r squared. So a portion of the area. Well, 45 over 360 I think is also going to simplify. Let's see what that comes out to be. Okay, it's about an eighth. Well, sorry, it is exactly an eighth. Okay, so we're talking about this little pizza slice is an eighth of the full pizza. Well, what's the area of the full pizza? It's pi times 15 squared. Okay. So we got to find out what 15 squared is, and then we'll kind of, put it all together. So 15 squared is 225. So 225 times pi. We can put this as a fraction if we want. So we have 1 times pi times 15 squared. All that together is 225 pi. And then 8 times 1 is 8. Okay, we're talking about miles. So this is a pretty big pizza if we're talking about miles. Pizza is just an analogy, but you get the idea. And since we're talking about area, we're talking about square miles, right? Not just a length measurement, but a two-dimensional area measurement. This is our exact answer. We can't simplify the fraction because there's no factors of 8 that go into 225. So we're kind of stuck there. Now we're going to want to change that to a decimal approximation, so that would be the next step. Okay? All right. Let's look at a couple of these. Now these are kind of funky, and I know I'm a super stickler for showing your work, but these problems, there's not a whole lot of work to show. So what I want you to do to show your work is just kind of label the figure to help you out. Okay, so AZ is congruent to CW, right? Those are the same length, and we know that CW is 2. So I would start by just labeling this length 2. Okay, and then you're going to kind of go from there, use some, segment addition ideas and subtraction and things like that to find out the rest of the sides. Now, if you want an example of this, there's actually one in your textbook. I just closed my textbook, so I forgot what page, but it is in section 8.1. I'll find that page for you really quick. Just give me a second. Sorry, not 8.1, it's in 10.1. I think I've been saying 8.1. This is in chapter 10. All this stuff is in chapter 10. But if you want a good example, you can look at this guy, example 3, which is on page 523. Okay? So do your best on those, see what you can come up with. This one is a little bit trickier, especially I think, maybe 43 might be a little tricky. But use ideas about radius and diameter and things like that to figure this out. You can assume that each one of these points is the center of a circle. And so you can assume like this is a diameter of circle J, or excuse me, a radius of circle J, and this is a radius of circle K, and this is a radius of circle G. So start with that information and see what you can come up with. Okay. On these last four, you're going to need to kind of combine some ideas about right triangles and circles. These guys right here, you're going to probably want to find this to begin with, because remember, to find circumference, we either need diameter or radius. Okay? So we're going to have to find a diameter or radius, and in this case, I would probably use Pythagorean theorem, but you're going to have to keep your answer as like a simplified rational if it comes out that way. In this case, in these two cases here, notice that what we have is 45, 45, 90s. So you can use that idea. Remember that the ratio in a 45, 45, 90 is square root of 2 to 1 or 1 to square root of 2. So whatever this is, you multiply it by root 2 to get to here. Whatever this is, you divide by root 2 to get to here. And so here we have this measurement for root 2. So think about how do you get to the hypotenuse from a leg. And then in this one, this is kind of hard to see, but this is what's labeled as 10 inches right here. Okay. So you got 10 here, you got 10 here. How would you get to this length? Okay, now, since this is the same length as this has to be a 45, 45, 90, right? So use those ratios that we talked about. Once again, to get from a leg to the hypotenuse, you multiply by root 2. If you want to go from hypotenuse to a leg, you have to divide by root 2. We want exact answers, though, so you need to keep track of those roots. Deal with those roots. Don't do a decimal approximation. And then once you find these are all going to be actually diameters, go from there and find the circumference. Okay? Do your best, show your work, and if you have any questions, you can shoot me an email, or we can spend a few minutes talking about it before or after class. Thanks, guys.